So this is meant to help you a bit more with that first worksheet you did on freefall kinematics. I'm just going to run through problem 3 for you. The most important part of solving a problem is to have a clear picture right at the beginning of everything that's going on. So make sure you've got the worksheet and problem 3 in front of you before you go any further. So I'm going to draw a diagram, and even though the ball goes straight up and down, in order to see more clearly what goes on, I'm going to draw it moving slightly sideways. So the ball starts at some point there, and it goes up. And as it goes up, it slows down, and then it turns around and comes back down again. And we want to try and assign numbers to this. So we know it's going to be launched at x equals 0 when t equals 0, and it's got an initial velocity that as yet we don't know. And its acceleration is acceleration due to gravity, minus 10 meters per second squared. And I say minus 10 because the other thing that's important to do is define your coordinate system. So I'm saying that up is the plus y direction, which means anything that's downwards is negative. So my initial velocity is upwards, even though I don't know how big it is yet. And it slows down on the way up. Got a little motion map here. And then it turns around and comes back down again. And since it's the same acceleration, the velocity is going to change by the same amount every second. So its velocity at equal heights is going to be the same. It's going to slow down from some velocity to 0 in the same amount of time it takes to speed up to that same velocity in the opposite direction, going the other way. So this is what the motion of this thing looks like. And I know that the final time, it takes 3.8 seconds to get back. That's the hang time that we're given. The final position is also 0. The final velocity, I don't know what it is yet, but I do know it's opposite to the initial velocity, so it's minus v0. And acceleration is the same throughout. Anything in free fall, 10 meters per second squared is the acceleration all the way through. We're asked to find what is its initial velocity. What is the value of v0 here? So this is about as complete a picture as I can get of this right now. I've defined my coordinate system, drawn a little picture that shows it going up and coming down again, and I've listed everything I know, including the things I don't know. And then all I've got to do is think about, okay, I know some kinematics equations that relate these various things. I know this equation that relates position to time and acceleration. I know this equation, and I know this equation. And don't forget that the delta x is just final position minus initial position. So if I look at all the things I know and look at the equations that I know, what I want to find is an equation that only has one unknown in it so that I can find another unknown. Now I know x, I know x0, I don't know the initial velocity, I know the acceleration, and I know the time. Look through that. This only has one unknown in it, the velocity, so I could use that to find that initial velocity. I don't know this or this, but I do know that they're equal. And I know this, and I know this. So this equation would work for me too. Since I know v and v0, one is minus the other. There's only one unknown variable in this equation, so I could use this one too. And this one, it turns out, if we look at it carefully, well, I know v and v0 squared, and I know they're equal, so that would cancel out. And my change in position over the whole time period, well, I go from x equals 0 to x equals 0, so that's 0. So this equation doesn't actually help me much because all it really shows is that 0 equals 0. But either of the other two I could use to find that initial velocity. And I'm going to leave you to do that. If you do it both ways, you're going to see that you get the same answer. But the basic approach you want to take, you need this picture. You really need this list of everything you know. And then you can use that to help figure out which of the equations is going to help you get the final answer.